Just the short announcement, there will be 20 minutes break after this talk. And I think we can start.
Should we start?
Mm-hmm.
Yeah. I'll just close this door. Okie dokie. Can everyone hear me up the back? Cool. So my name's Andrew Beekhof. I'm an engineer at Red Hat. One of the hats I wear is helping teams with high availability. So that's what I'm going to be talking to you about today in the context of Openstack. So I'm going to give a bit of background, which will hopefully put the architecture in some context. I'll cover the architecture, and then hopefully we'll have time for questions at the end. I'd like to start by telling a bit of a story. I'd like you to meet Debbie. Debbie is a database, but she's not just any database. She's a distributed and replicated database. So one of the things you'll hear about these sorts of applications is we don't need a cluster manager because our application is already fault tolerant. Okay, well let's see how that goes. So we'll fail a node, no problem. We've got three more. That's fine. How about we fail another one? There we go. Still no problem. Or is there? Is there enough capacity in those two remaining ones to fulfill all the requests? Maybe not. Maybe yours does, maybe this one doesn't. Maybe there was like 14 other instances down to the last two. So maybe it's important to bring some of those old instances back so that we can handle the load. So we've got a problem. If the reason those two nodes were gone was not some kind of transient failure, you can end up in a split brain. So neither side of this split has got enough context to know what to do next. All right? So you need to do things like, and the hardest part is that this is actually complete from each side. It's indistinguishable. What on earth is this doing? Right, it's indistinguishable from that. That's what each side sees. All right. If you're stateless and non-replicated, you might be okay. But Debbie isn't, so what do? We can introduce things like quorum. So you've got to have a majority. It's not going to work here. So then you have to introduce more things like tiebreakers. And you also, very importantly, you need fencing. Because if neither side knows the state of the other, you're going to be in trouble. You're going to end up corrupting your data. And so you need to be sure that the nodes you can't see are dead. So that's where fencing comes in. Can you do this without a cluster manager? Sure. It's not trivial. You can use things like watchdogs for fencing. If you've got static data, you're fine. Otherwise, you need some sort of merging algorithm. And you'll have a custom quorum implementation. All right, so you could be okay. If that's the only thing in the system, yeah, okay, job done. But no installation looks like this. All right, applications always roam in packs. What's it going to do? So you have not just a database, you'll have, say, a web server sitting on top of it. Okay? And now you need to think about, well, how do we organize the startup of this? Do you want the web server running without the database? Possibly not. So you need some sort of state machine that's going to enforce a deterministic behavior. And so we call this node HA. And an example of that is like your modern init system, like systemd. And they'll even let you go with like non-linear dependency trees, which is cool and gives you faster startup times. So now the messaging is no longer our application's fault tolerant, so we don't need a cluster manager. Now we don't need a cluster manager because we've got systemd, for example. All right? But with this too, you're going to run into pitfalls. Startup is usually where these pitfalls come. All right? So here we've got the database running by itself down on the 4th node. Is that okay? Is it okay if it stays like that? Possibly. What about if we do something a bit more complex? What if one node doesn't come up at all? Do we know if that node's dead? Do we know if that node's dead at all? What state is it in? What if the first node to come up was not the last node to come down? Have you lost anything? Do you need to care? A lot of the times you probably do. And what happens if the the Apache starts somewhere before the database? Does it matter if the database is active everywhere before any instance of Apache starts? These things matter. So node HA can be sufficient if the applications can be started and stopped in any order. If it doesn't matter when things come up and down. But in practice, many systems have very complex bootstrapping and startup requirements. The other problem to overcome is if you're using Watchdog for fencing, you can only have one thing that's doing fencing. You can only have one thing that has the Watchdog open, so you need to start coordinating fencing. So things start to become a bit more complex as you add them together. So here's an example from Openstack, Bootstrapping Rabbit MQ. All right. So first we've got to pick an active node. We've got to know which nodes are active. We've got to pick one and start Rabbit there. And then we've got to go to all the other nodes. We've got to tell them first of all, we've got to start Rabbit, and then we've got to stop part of it. And then we've got to tell them which node we picked to be the first one, and then we've got to tell them to join the cluster at that first one, and then we can bring the rest of Rabbit MQ back up. All right. Now your node and application HA can kick in, but you need something smarter to get you to that point. All right? And this is the sort of thing that cluster managers do for breakfast. So I like to define a term called system HA. So it's holistic. It's not just looking at an application. It's not just looking at a node. It has to take into account the entire system in order to make intelligent decisions. So because you're bootstrapping multiple applications on multiple nodes. So in system HA, you often don't care if the two applications are running on the same node. You just, for example, in Openstack, you just need some Keystone instances running, and then you can start running Cinder. You don't actually need them to be on the same machine. And that's something we take advantage of later. But even then, you probably don't want that. What you probably want is more like that. So you want to hide each of these services behind a virtual IP, right? So that you can avoid the end-to-end mesh. And so a cluster manager can coordinate. You can bring up the Keystone instances and then start the virtual IP. It can bring up Cinder and then the Cinder VIP, right? And it can just bring this whole system up and bring it to life reliably across multiple machines. So it gives you higher availability because you've reduced startup and recovery times, and it more closely models the environment that you have, right? And it takes on the complexity so that your applications don't have to. You can add all this stuff to each individual application and get the same result, but every time you do, you run the risk of bugs. Because everyone's got their own implementation, they're all going to have their own bugs as well. And you increase the risk of internal split brain. Shouldn't have gone out drinking last night. So internal split brain is when you've got two parts of a system pulling in opposite directions. So if Keystone has one view of the world and Cinder has another, and they start pulling in the opposite direction, the result is that everything comes crashing down. So here's the difference. Cinder, Node HA allows you to say things like, don't start Cinder until Keystone is up. Right? System HA lets you say, Cinder can run as long as Keystone is up, anywhere. And one particular cluster manager, we're working on the feature where you can say, Cinder can run as long as a specific number of Keystone instances are active. So this is the sort of benefit that a cluster manager can bring. So yes, System HA is possible without a cluster manager, but you should still use one. So now that we've sort of talked about the benefits of a cluster manager, we can have a look at how it applies to Openstack. So after extensive experimentation, this is your rough startup order of an Openstack installation. So things along this way can be started in parallel, but then you can't start the next level up until that's all done. Okay? And there's these couple of lines represent sort of settling periods. You need usually an artificial kind of wait in there to let everything settle and be ready to move on. So the way we came up with this is to basically create a cluster using every single component. So the idea is that each component needs to be able to run isolated from the rest. And this is really handy because it lets you find the dependencies between things. It lets you, in terms of network security, you can lock down things a lot more because there's only sort of maybe one port in and one port out. So you've got much finer granularity there. It also helps, find those interdependencies for the startup order and spot weaknesses in the network protocols. For each cluster, we prefer you have an odd number of nodes, just so that quorum makes a bit more sense. You don't need an extra tiebreaker in there. So we recommend 3 nodes and up. And each cluster can scale to a maximum of 16 nodes. So that helps when there's a particular part of the system that's maybe lacking in performance, you need to add some more capacity, you can go up to 16 nodes for that particular component. So yeah, as I said, everything should be capable of running in its own isolated cluster, but you can collapse it at the end down to a single cluster, a single 3-node cluster. And we'll see what that looks like as well. You may have seen on that a couple of slides back, there was an LB. So LB is load balancer. The reason you want the load balancer is so that you can then hide these nodes, multiple nodes or clusters behind a single address. So they help with that. In some cases, even though Galera is running active-active, you suffer from lock contention, so the load balancer can actually help, the routing you use for that can actually direct all the writes to one specific machine, but then can fail over. It eases your maintenance, hiding things behind an IP address. So if you need extra capacity in Galera, you throw an extra instance at it. You don't need to reconfigure Ceilometer or Glance, for example. And it gives you a second redundancy in health checking. So the cluster is checking the services on the local machine, but then you've got another way in to detect failures. So the load balancer can take that role on for you. So as I said, fine grained ACLs, there's a one-to-one match between the IPs and the APIs that are being exposed by each service. You don't run into port clashing. The initial setup is more complex and does require more IPs, but in the long run, it's worth it. So this is the cluster status from one of our load balancers. You'll see basically everything's got. There's a Cupid there instead. You see everything has its own IP address. The IP addresses themselves are distributed through the cluster, and HA proxy is running on all three nodes. One thing that might be conspicuously absent from that is Rabbit MQ. That's still in a bit of flux. There's some technical issues running Rabbit MQ behind the load balancer. So at the moment, the decision is to expose that directly. So this is kind of what it looks like, putting it all together. Each block here corresponds to a 3 or more node cluster. Various things hanging off shared storage. We've got the key up here for active-active. Pretty much everything is at active-active at the moment. In some cases, we're still at mixed. So the load balance, even though it's running in an active-active configuration, the load balancer is funneling traffic in one particular place. The reds are more interesting, and I'm going to get to them in a minute. Each of these is actually a single node cluster, and I'll get into why we do that in a second. So compute and Swift nodes run as single node clusters. The reason is that there's way more than 16 of them, and that's the upper limit for what we support for the cluster manager. So what do you do next? You still want the ability to monitor services, to recover them, to do all the good stuff, but you need to be able to scale well beyond that. And so single node clusters are a way to achieve that. Consistent management is also another feature there. So the same things that you're running on the cluster, on the control plane, you're also running on the other nodes as well. One of the things we are looking at for this is to bring them into the... So the limit on 16 comes from a package or a project called Corusync. So that's what provides the messaging and membership for the cluster manager. That doesn't like going so far over 16 nodes due to just a limitation in the protocol called Totem. We have a notion to do an end run around this and have something like Pacemaker Remote which you may or may not have heard of. Basically, it's a way for us to reach out to a machine and have it sort of, so you have like your ring topology for totem, and that's all your control plane, and then you reach out to the compute and Swift nodes through Pacemaker Remote, and that gives you a way to start and stop services as if it was part of the cluster without the overhead of totem. So that's something that we're looking at for a future release. Yeah. So the other end of the spectrum is when you condense this all down onto a single cluster. And basically everything, not much really changes. On the services side, they're just all on, the machines are all the same machines. It simplifies your network setup a little. And then you've still got the compute and Swift nodes as single node clusters. Some of the decisions being made in here, Galera active passive, active active, as I said, due to lock contention. We run it active active, but have the load balancer funnel all the writes to a single machine. Galera versus MySQL. Galera and Rabbit MQ were both added to the Red Hat stack by popular demand from the user base or customers. Nova Networking and Neutron. The tendency is to head toward Neutron. And as I said, the problems with load balancer for Rabbit MQ. There is a thought that we have a handle on that, and that could be reappearing as part of the official architecture soon. Challenges, as I said, the cluster only scales to 16 nodes for RHEL 6 and 7. We're looking at, first of all, increasing that limit in future releases. Multiple sites when you want your OpenStack installation to span multiple sites. So there's challenges in how we do that and how the cluster spans multiple sites. It particularly gets interesting when you think about fencing. If you've lost access to the entire site, how do you control the network or the power switches in that site? So you need to make some assumptions and add some extra functionality for that. It can be very difficult to deploy. It's hovering around 20 Etherpads and many thousands of lines of how to. So it is complex to configure this whole thing. And when you've separated things out into a cluster per service, the inter-service dependencies are very tricky to get right. We've got a couple of options that we're looking at on how to have cross-cluster dependencies. It's not something that we've dealt with before, so yeah, we're making progress there. And it's very complex to debug. Either way you do it. So we've plowed through really fast. In summary, cluster managers are here to help. Please don't reinvent the wheel, please. We've made a lot of mistakes for you. Please take advantage of that. Be careful when bootstrapping replicated applications. And be careful when designing replicated applications would be my very best advice. Pay attention to these things early on, and they won't come back to bite you at the end. Manual setup is long and complex. Use an installer like Stay Puft. Stay Puft will generally install the everything on one single cluster. I think that's the one that it goes with. And things that are coming, Pacemaker Remote, for instance, high availability, and read-only resources for inter-cluster ordering. So that's how we'll get around that. We have plenty of time for questions today, so please don't be shy. Nothing at all.
Are you up,
Yeah.
Andrew?
Michael.
Is this complete setup documented, as you said, in the
Yes. It is documented internally. There's an effort underway to make that suitable for wider consumption. Yeah, but generally, don't do it yourself. Use an installer. Pick the pieces that you want. Yeah. Any questions about why the cluster manager is involved? Anyone still convinced that you can just use keep alive D and get everything? Okay. Okay. Well, I'm done. Go have lunch, everyone.
Oh, are you the
next one.
the next one? All right. So you have plenty of time. Go enjoy your lunch.
Yeah, yeah.
But you should be here like 10 minutes.